In this clip, we will show how to do a one-way analysis of variance and how to test for linear trends. For this demonstration, we will use the food company data that is already opened. In this data, the dependent variable is sales, and the factor variables are design and store size. Design has 4 levels, and store size has 5 levels. Store size represents comparable store sizes from 1, which is the smallest store, to 5, which is the largest store. To test the effect of designs on sales, we will use one-way Anova. So go to the Analyze menu, Compare Means, and One-Way Anova. The One-Way Anova dialog box allows us to select all the dependent variables we have. In this case, sales is the only dependent variable. The factor we are going to select is design. We would also like to see if there is a significant difference between the 4 designs. If there is a difference, we would like to know which designs differ from the others. To do this, go to Post Hoc and select the appropriate tests. Usually, you select Tukey, which is appropriate if you have a large number of comparisons to make. And if you have a small number of comparisons to make, Bonferroni is optimal. And now click Continue. You should note that in practice, one would usually run an F-test first to see if a post hoc test is needed. Under Options, we can choose to test the equality of variance among different designs. In this sub-dialog box, we will select Descriptive Statistics and the test for homogeneity of variance. If the variances are not equal, either the Brown and Forsyth test or the Welch test could be used to test for equality of group means. Now click Continue and click OK. In the output window, you are first given the descriptives. Then there is the test for homogeneity of variances. The p-value of this test is 0.729. Therefore, we cannot say the variances are different. Next is the Anova Table, and this shows that there is a significant difference between the 4 designs. Now the question is, which designs differ from the others? And this is what the post hoc tests will show us. You can tell when groups differ because they will be marked with an asterisk. For example here, Design 1 differs from Design 4, Design 2 differs from Design 4, and Design 3 differs from Design 4. Bonferroni gives us the same results. If you look at the homogeneous subsets, the same results are displayed. This shows that one group can be comprised of designs 2, 1, and 3, because we cannot say there is a difference in these designs. And another group is comprised of design 4. To test if sales are increasing across the ordered levels of store size, we will use Anova with store size as the factor. Go to the Analyze menu, Compare Means, and select One-Way Anova. Let us reset these selections, and I will re-enter sales as the dependent variable, but this time enter store size as the factor. Now click on Contrasts and select Polynomial and leave the degree as linear for linear trends. Click Continue and click OK. Here's our output. We can see by looking at the p-values that we cannot say that sales are increasing across the ordered levels of store size. Now you know how to perform a one-way ANOVA and how to test for linear trends.